All right, so like I said, we're going to be solving absolute value equations first, and we're going to call this is a continuation of your notes from the other day. So we're going to call this checking for extraneous solutions. Checking for extraneous solutions. And an extraneous solution is derived from the original equation but does not make the equation true when checked. All right, in algebra, all right, algebra 1, algebra 2, college algebra, you're always told to check your answers. Check your answer, check your answer, check your answer. Well, an extraneous solution is what I call an extra solution. It's a solution that you're going to get mathematically, but when you substitute it back into the original equation, it doesn't work. It doesn't make the equation true. It's called an extraneous solution. So we're going to do a couple of examples here where we're going to solve the inequality the way that we're supposed to, or in this case, we're going to solve this absolute value equation. We got 3x plus 2 equal to the absolute value of 3x plus 2 equal to 4x plus 5. So we've got the absolute value symbol on the left by itself. We talked about that the other day. The next step was to rewrite the equation twice, dropping the absolute value symbol. But be careful because there's more on the right side than just a whole number. So we're going to write 3x plus 2 is equal to 4x plus 5. And then we're going to write this as 3x plus 2 is equal to negative, or the opposite of 4x plus 5. And this is where you got to be careful in this step. We're going to solve on the left first. So if I subtract 3x from each side, we get 2 is equal to x plus 5. Subtract 5 from each side. We get a solution of 3 is equal to x. Now, on this equation on the right, the first thing we need to do, yes. Yeah, negative 3, I'm sorry. 2 minus 5 is a negative 3. Thank you. In this second equation that we wrote, we have to distribute this negative. So our 3x plus 2 is equal to negative 4x minus 5. So I'm going to add 4x to each side. And 7x plus 2 is equal to -5. Subtract 2 from each side. So 7x is equal to -7. Divide both sides by 7. And we get an x equal to -1. Now, when the directions tell you to check for extraneous solutions, that means you have to substitute both of these back into the original equation to see what works. All right? So I'm going to substitute the -3 first. And the absolute value of 3 times -3 plus 2, is that equal to 4 times -3 plus 5? So on the left-hand side, 3 times -3 is -9 plus 2 is -7, right? Good. So we get the absolute value of -7. Is that equal to 4 times -3 is -12, and -12 plus 5 is -7. Now, can an absolute value ever be equal to a negative? It can't, can it? So anytime you have an absolute value equal to a negative, that would be called extraneous. The -3 is called an extraneous solution, so we don't use it. Let's check this -1. We're going to take the absolute value of 3 times -1 plus 2 and see if it's equal to 4 times -1 plus 2. 4 times -1 plus 5, sorry. So on the left-hand side, we get the absolute value. 3 times -1 is -3 plus 2 is -1. 4 times -1 is -4 plus 5 is +1. And is the absolute value of -1 equal to 1? It is, isn't it? Okay. So this solution works. This solution is good. So x equal to -1 is a good solution. The other solution is called extraneous. Okay? All right, does anybody need to see another one of those examples? This is kind of a key step right here. So be real careful there. All right, when you rewrite the equation the second time, you've got to apply this negative symbol to everything on the right-hand side. All right, you got to distribute a -1. So that's -1 times 4x is -4x. -1 times 5 is -5. Make sure you complete that step. All right, second part of your notes. We're going to be solving the absolute value of an expression, or A, being less than a quantity. Absolute value less than a quantity. So if we have something like the absolute value of 2x minus 1 is less than 5. All we're going to do in this case is we're going to rewrite the equation and we're going to drop the absolute value symbol. But we're going to do one other thing too. Here's what we're going to do. We're going to rewrite this as 2x minus 1 is less than 5. And now watch. We're just going to put a less than symbol and the opposite of this 5. Okay? So we rewrite it by dropping the absolute value symbol. And then whatever this quantity is, we add the same inequality symbol. And then we add the opposite of the original quantity. So now we just add 1 to the middle, to the right side, and to the left side. We get negative 4 is less than 2x, which is less than 6. And then we can divide everything by 2. And negative 4 divided by 2 is negative 2 is less than x, which is less than 3. When we graph it, we plot the negative 2, we plot the 3. We're open on both. And let's see, negative 2 is less than x, and x is less than 3. So we're everything in between. All right, let's do one more of those. Let's take a look at the absolute value of 3x minus 4. And it's less than or equal to 8. So it doesn't matter when you do it. You can do it now if you want. You can just put the negative 8 right here. Negative 8 is less than or equal to 3x plus 4, which is less than or equal to 8. Subtract 4 from everything. Negative 8 minus 4 is negative 12 is less than or equal to 3x, which is less than or equal to 4. And then divide everything by 3. So we get negative 4 is less than or equal to x, which is less than or equal to 4/3. Yeah.
Why is it 3x plus 4? No.
Because I wrote the problem wrong. So, man, sorry about that. So that'll make that a 12, right? I'm just going to start over. You guys can fix it on your paper if you want to. I'm just going to rewrite it. Negative 8 less than or equal to 3x minus 4 less than or equal to 8. So it's going to be add 4 everywhere. So -4 less than or equal to 3x less than or equal to 12. Divide by 3. And -4/3 less than or equal to x less than or equal to 4. On the graph, we've got the -4/3 and the +4. Since it's less than or equal to, it's including those points, so it's a solid dot. And we're going to shade in the middle. All right, sorry about the mix-up there. Everybody okay with those type of inequalities? All right, then the last type of inequality you're going to see today is when the absolute value is greater than, or it's greater than or equal to. So we've got, or we're going to be solving when the absolute value is greater than so we got the absolute value of 2x plus 4 greater than or equal to 6. Now, when this inequality is pointing to the right, or when it's greater than, it's very similar to what you did on Monday. We have to rewrite two equations now. We're going to rewrite it as 2x plus 4 greater than or equal to 6. And now when we rewrite this second equation, be careful. We're going to write it as 2x plus 4 less than or equal to -6. So we're rewriting it once just the way it is, dropping the absolute value symbol. When we rewrite the second equation, we're going to change the direction of the inequality and negate the quantity to the right of it. Then you're just going to solve both of these inequalities. So subtract 4 from each side on the left. Get a 2x greater than or equal to 2. Divide both sides by 2. And x is greater than or equal to 1. Solve the second equation as you normally would. So subtract 4. 2x is less than or equal to -10. Divide both sides by 2. X is less than or equal to -5. And then when you graph that, we got a -5 and a 1. So -5 on the number line and 1 on the number line. We're less than or equal to -5. So we're closed circle and we're shaded to the left. Everything less than -5. We're closed on the 1. And it's everything greater than the 1. All right, so let's do one more of these. And then I'll give you some practice on your own. Let's look at the absolute value of 5x plus 10. Greater than 15. So rewrite it just the way it is. 5x plus 10 greater than 15. And then 5x plus 10. We're going to change the direction of the inequality. And we're going to negate 15. So negative 15. And then we'll solve them both. So we get a 5x greater than 5. Divide both sides by 5. We get an x that's greater than 1. And then subtract 10 from each side. Get a 5x that's less than negative 25. Divide both sides by 5. And our x is less than negative 5. When we graph that, we got the negative 5 on the graph, and we got a positive 1. We're greater than 1, so we're open. We're going to the right. And we're less than negative 5, so we're open. And we're going to the left. To the left. All right, any questions? All right, then your practice for today is going to be on that page 46 again. Let's see. Do 22 through 27. And then 31 to 33.